relationships versus non-proportional relationships. If two quantities happen to be proportional, then they will have what's called a constant rate of change, which is basically every single set of ratios in a problem will have an equivalent unit rate. So let's go ahead and get that written down. That's very important to understand. If two quantities are considered to be proportional, if they have a constant ratio or a constant rate or a unit rate throughout. So if the ratios, if the quantities that you're comparing, if the quantities do not have anything consistent, so the quantities are not constant, meaning that they do not have the same unit rate. So when you simplify it, it does not come out to the same unit rate, then it is non-proportional. Okay? So let's say that we've got Andrew, and Andrew's going to earn $18 an hour mowing lawns in his neighborhood. Earns $18 an hour mowing lawns. So what I want to know is the amount of money proportional to the hours that he works. Is the amount of money going to be proportional to the hours that he works? So we're talking about the hours compared to the money. So we're going to make a little table. If he works for 1 hour, thank you. If he works, yeah, $18. If he works for 1 hour, how much money is he going to make? $18. If he works 1 hour, he's going to make $18. If he were to work 2 hours, how much money would he make? $36. If he works 3 hours, how much? $54. Good. What about 4 hours? $72. Okay, so we want to make a table that's consisting of several points of data, and then we want to see, okay, are they going to be the same unit rate? So we're going to take the $18 and divide it by 1. If he takes 18 and divides it by 1, what is he going to get? 18. Okay, then we're going to take $36 and divide it by 2. What does he get? 18. Take 54, divide it by 3, get 18. Take 72, divide it by 4, he gets 18. The fact that the rate is the same from every single one of these ratios, they're all equal, then it means it is a proportional relationship. Because every single thing is the same throughout the entire problem, it does consist of a proportional relationship. Take a moment to get that down. In about 10 seconds, I'm going to switch it to the next page. All right, let me switch it. Wow. Okay, all right. Not 1 minute. Okay. Okay, I gotta go. Sorry. I gotta switch it, guys. It will be on there tonight. It will be on there. All right, next question. Uptown Tickets is going to charge $7 per basketball ticket, or per basketball game, sorry. No, we're not getting into that. Stop. Okay, so they're going to charge $7 per basketball game plus a $3 one-time processing fee. For the entire order. So I want to know, is this going to be a proportional relationship? So what are we comparing? Tickets and what? And the, not the game, but tickets compares to the price, right? Tickets compared to the cost. So you're comparing how many tickets you can get to the cost that you're going to have to spend for those tickets. Now, you're charged $7 for every single ticket that you want to buy, but then when you purchase your tickets, you're charged a $3 processing fee. That processing fee is charged whether you have 1 ticket or 50 tickets. You're just paying $3. Is that understood? That's what it means by a one-time processing fee for the entire order. So if my order is just for 1 ticket, I'm paying that $3 for just the 1 ticket. If my order is going to consist of 10 tickets, I'm still just paying a $3 fee, and I can buy my 10 tickets at $7 each. Okay? So with that in mind, if I want to go ahead and compare the tickets to the cost that I'm going to spend, if I buy 1 ticket, what is the total cost going to be for that 1 ticket in my order? $10. $7 for the ticket, and then $3 to process it. So $10 is what I'm going to pay. Now, let's say instead of paying for 1 ticket, I decide I want to pay 2 tickets in that order. What is that cost going to be? $17. Good. $17 because you're paying $7 for each of the tickets. So $7 for 1 ticket, $7 for another ticket, that's $14. And then your $3 processing fee. So 14 plus the 3 gives you 17. If I pay for 3 tickets in my order, what will that be? 24. Good. Again, 3 times 7 is $21 for just the tickets, plus your one-time $3 processing fee. Okay, so again, it does not matter how many tickets you buy. You pay that $3 just one time, but you pay that $7 for as many tickets as you've got. So 4 tickets is going to cost $31. Good. Yeah. So you take how many tickets you're buying and you're multiplying it by $7 for each of the tickets, and then you add that one-time processing fee. Okay? All right, so this is our table so far. Now we've got to compare it and see, do each of them simplify to the exact same unit rate? So we're going to take the cost and divide it by the item. So what's 10 divided by 1? 10. Serious. What's 17 divided by 2? Uh-huh. Yep. Serious, we're getting you a new seat by me at the end of class. Okay? 24 divided by 3. Alex. Good. And then 31 divided by 4. Kingston. 7.75. So if we're talking about money, this is $10 per, or $10 for the unit rate, $8.50 for the unit rate, $8 for the unit rate, $7.75 for the unit rate. Is that proportional? No. Why not? They're not the same, right? It's not consistent. It's constantly changing. They are not equal. That's what this means. If I put an equal sign with a slash through it, it's not equal to each other. So since they are not equal, it is non-proportional. If it is not equal to each other, then it is a non-proportional relationship. Any questions about the difference between proportional and non-proportional? Yes. You're going to learn how to write write what? Like create your own scenario? Not on the test. You won't be doing that. You won't be creating your own situation, but you will be doing things like, finish the chart. If this is a proportional relationship and this is what the table looks like, and then I say, hey, the next one's 5, what will X be? You'll finish the table. You'll have things where you'll be given the table is at a proportional relationship or not, doing different stuff like that. And of course, there's a whole lot more that we still need to cover in the unit that's going to be on there. But like I said, this tends to be our easier unit. Okay? Yeah. A lot of stuff we just continue and build on. All right, so I want you to try these next 3 problems on your own. Create your table and identify if it's proportional or not. Serious. Come on. Start writing it down. Don't suck your teeth at me. Alex, I don't need your commentary. That was EJ? EJ, shut it. as a reminder, who can tell me what does deposit mean again? To add. Deposit means you're adding into an account. Withdraw means that you would take away from an account. So if I'm saying he's depositing money, he's putting money into his account. Yes, Mohammed? You go ahead and you decide, okay, I'm going to just do first day, second day, third day. I usually say do 4 points, 4 sets of data. Remember in the tables, I always do like, oh, first ticket, second ticket, third ticket, fourth ticket. Same thing, do first day, second day, third day, fourth day when you create your table. For every 2 points. Yeah. Staffing quizzes at 3:45. Serious? After notes are done, if we have time. Bless you. Yeah.
So for number 2, you setting up your table, you have like half, how many cups did you make in half? I'm confused on this one. How would I set up that table?
You would do a half over 2.
Oh, okay, so then. Oh, okay, alright.
Is there like this one like
You can do it that way too, yeah. It says that this way. It's fine.
Also,
and then you're good.
Are they right? So all of them would be over 2?
No.
I don't know. Okay, alright.
All right, let's go ahead and go over number 3. Number 3, AJ. Yes, it is proportional. So if we were to compare the miles to the days, you can do it as days over miles. So I usually go ahead and focus on how many days that I'm walking versus the miles. So the days that I'm walking, I walk 1 day, it's 6 miles. If she's going to walk 2 days, it's 12 miles. She walks 3 days, it's 18 miles. She walks 4 days, it's 24 miles. So then if she simplifies it, 6 divided by 1 is 6. 12 divided by 2, good. 18 divided by 3, 6. 24 divided by 4, 6. They're all equal to each other, so it is a proportional relationship. Kimberly. So that's a very good question. What we usually do when we set up the table, we set it up as X compared to Y. Your X is going to be the, we always let that be time. Time is typically going to be your X-axis values. Y-axis values would typically be money. So if you're ever doing something that's comparing time, whether it's hours, minutes, days, weeks, that would always be your X value. So you would put that as your X variable. And then your Y would be whatever's remaining. If it's money, you would always put money as your Y. Okay? All right, for problem 4. Problem 4, is that proportional or not proportional? Whoa, it's actually proportional. We're going to talk about it. Quiet. Has to be equal. Equal, not even, equal. Okay, they have to be equal to each other for it to be proportional. Yes. Not right now. Okay, so the reason that this is proportional, again, so I'm going to go ahead and put sugar compared to juice. I'm going to put sugar compared to juice. So in the problem, it says half a cup of sugar for 2 quarts of juice. So I'm going to go ahead and put half a cup for 2 quarts. So I want to try to stay consistent with how I'm working through this. So since juice is being calculated by every 2 quarts, so what's the next set of quarts going to be then? 4. So if I have 4 quarts of juice, how much sugar would I have? 1 cup. If I have 6 cups of juice, how much sugar? 1 1/2. Okay, and then 8 cups of juice would give me 2 cups of sugar. Now, if you were to go ahead and find whether it has a consistent unit rate, 2 divided by 1/2. 2 divided by 1/2 is 4. 4 divided by 1 is 4. 4 divided by 1 is not 4. 6 divided by 1 1/2 is 4. 8 divided by 2 is 4. You're going to have it consistent throughout, so it is proportional. It is proportional, yes. Yeah, you got to be careful about that. All right, number 5, proportional or not proportional? Non-proportional, very good. So we're going to talk about comparing the weeks to the amount of money that he's got in his account. So the very first week, how much total money will he have in his account? 140, good. He'll have $140 at the end of the first week because he started off with $120, but then he put $20 in, so it's $140. If By the end of week 2, how much money? By the end of week 2, $160. He's only depositing $20 every single week. End of week 3, he's going to have $180. End of week 4, he's going to have $200. Good. So then trying to check to see whether it is proportional or not. Again, we're going to take 140, divide it by 1, and we're going to get 140. Take 160, divide it by 2, and we're going to get 80. Take 180, divide it by 3, we're going to get 60. Take 200, divide it by 4, you're going to get 50. It's not the same unit rate throughout. Okay, these are not equal to each other. So that's why it is non-proportional. Now, a really quick way to be able to tell whether a word problem is going to be proportional or not without having to make a table. If you notice, every one of the problems that was proportional did not have a constant, meaning it did not have a one-time value. But problem 5 and problem 2, they both had a constant, didn't they? They had a one-time value. Starting price of $120 in his account. That is a constant. Having a one-time processing fee. That is a constant. So if the problem has a constant in it, then it means it's not going to be a proportional relationship. So that's just a little trick to see. All right, your assignment tonight, you have plenty of time. You've got 20 minutes in class to be able to work on it. You may listen to music if you would like. That's perfectly fine. But one thing I want to show you real quickly, for a problem like number 1, 2, and 3, they're asking you to write ratios. So if you take a look here, it's asking you to set up, so they're giving you the table. Everybody look up at the board so you can see it. They're giving you the table. They're saying, hey, number of hours is 1, 2, 3, 4. Money earned is 15, 30, 45, 60. They want the ratio of earned to hours. So what goes on top? 15 over 1, 30 over 2, 45 over 3, and 60 over 4. So when you have to read the problem carefully to see what do they want the ratio set up as. Earned over hours, cost over packages, students over classrooms, that sort of thing. Okay? You know,